Okay, question 11, we got binomial expansion on steroids. So part A wants us to use the binomial expansion to show that the square root of 1 add 4x over 1 minus x is approximately 1 add 5 halves x minus 5 eighths x squared, and it's 6 marks. So, what we need to do is realise that we have two binomial expansions here. So, root 1 add 4x over 1 minus x is root 1 add 4x over root 1 minus x. Now in power form, we've got 1 add 4x to the power of a half times 1 minus x to the power of minus 1 half. So what we need to do is find the first few terms in each of these expansions. Now they only want us to go up to the x squared term, thank God, so we only need to go up to the x squared term in each of these expansions. So, we're given the formula, so let's do 1 add 4x to the half first. So 1 add 4x to the half is approximately, okay, so the formula is in the formula sheet, which you can get down below, remember. So we're going to use this guy. 1 add x to the n is 1 add nx add n times n minus 1 over 1 times 2x squared. So for us, x is 4x. So we're going to get 1 add nx. So n is our power, so 1 half lots of 4x. Add n times n minus 1 over 2x squared. So that's going to be a half times a half minus 1 minus a half times 4x all squared over 2. So we're going to get 1 add 2x. Okay, then over here we got 1 half times minus a half is minus a quarter. 4x all squared is 16x squared. So minus a quarter times 16x squared is minus 4x squared. So we got minus 4x squared over 2. So we got minus 2x squared. So that's that one. So now we're going to do 1 minus x to the minus half. So 1 minus x to the minus half is approximately 1. Then it's add nx, so that's going to be add minus a half times minus x, so that's going to be add 1 half x. Okay, and then we're going to get add n, so minus a half, times n minus 1, so minus 3 halves, times minus x all squared, so that's going to be positive x squared, and then that is all over 2. So here we go. 1 add 1 half x, and now we got, so 1 half, minus a half times minus 3 halves is positive 3 quarters. So we got 3 quarters x squared divided by 2, so that's 3/8 x squared. Okay, so now we got the two separate expansions. We can say that 1 add 4x to the half times 1 minus x to the minus half is approximately equal to 1 add 2x minus 2x squared times 1 add a half x add 3/8 x squared. Okay, so we need the constant term, so that's nice. That's just going to be 1 times 1, so there's the 1 that we wanted. And then we need every x term that we're going to get. So we're going to get 1 times a half x, so that's going to give us a half x, and we are going to get 2x times 1, so that's 2x, and then we want every x squared term that we're going to get. Purple. Okay, so we're going to get 1 times 3/8 x squared. We're going to get 2x times a half x. So that's going to give us 1x squared. And we're going to get minus 2x squared times 1. So that's minus 2x squared. And then we're going to get 1 times, where is that? That's it for all of the x squared terms. So let's sharpen this up. So we got 1 add, now a half x add 2x, or 2x is 4 halves x, so that's 5 halves x. And then we got, let's see, so we got, let's worry about the whole x squareds first. So we got plus 1x squared minus 2x squared, so that's minus 1x squared. And then we got add 3x. x squared. So minus 1x squared is minus 8 x squared. So add 3x onto that and we get minus 5/8 x squared as we wanted. So, job done. Okay, then we're told a student substitutes x equals 1/2 into both sides of the approximation shown in part A in an attempt to find an approximation for root 6. Part B, for 1 mark, wants us to give a reason why they should not use x equals 1/2. Okay, so in the formula book we are told that for the expansion of 1 add x to the n, it's only valid for values of x such that the modulus of x is less than 1. So up on top where we have so for 1 add 4x to the power 1/2 to be valid, four times the modulus of x has to be less than 1 because we have 4x, not just x. So that means the modulus of x has to be less than 1/4. Now 1/2 is bigger than 1/4, so is not valid. Cool. Okay, then for part C, we are substituting in x equals 1/11 into our expansion to obtain an approximation for root 6. Give your answer as a fraction in its simplest form. Okay, so we are putting then x equals 1/11 into this guy. So x equals 1/11 is going to give us well, it's going to give us the square root of 1 add 4/11 over 1 minus 1/11. So let's just worry about simplifying that for the moment. So that's going to give us 11/11 add 4/11. So that's square root 15/11 over 10/11. Now we have a common factor on the top and bottom of 11, or 1/11. So this is actually just root 3/2, which we can think of as root 3/2. So at the moment, that's the left-hand side. So we're going to get then that root 3/2 is approximately equal to so 1 add 5/2 times 1/11 minus minus 5/8 times 1/11 squared. So root 3/2 is approximately 1 add 5 over 22 minus 5/8 times 1 over 121. Lovely. Right, so we're going to get root 3 over root 2 is approximately 1 add 5 over 22 minus 5/8 times 121 is 5 over 968, I believe. Good times. Right, at that point, it's probably easiest just to use your calculators. I'm stubborn though, so 1 in terms of 968 is 968. 968. 22 is probably going to go into 968. Also going to be 96 divided by 22 is 4. Carry the 8. It's going to be 44. So we're going to need to multiply 5 by 44, which is going to give us 220 over 968 minus 5 over 968. Okay, so root 3 over root 2 is approximately, so 968 add 220 is 1188. So we got 1188 on top minus 5, so we get 1183 over 968. Okay, so we wanted root 6. So how does this tie into root 6? Well, rationalise the denominator on the left, and we will get root 6 over 2 is approximately 1183 over 968. So if we then multiply 3 by 2, we get root 6 is approximately 1183 over half of 968, which is 484. That is our approximation for root 6. Cool.